Thank you for everyone has showed here physically, despite the weather. So today I'll talk about multi-cluster deployments and how we have solved that here in Telenor Norway. My name is Aksel Skaar Leirvaag. I work as a platform engineer. I'm on a team with 6 people. We're mostly dealing the application layer, meaning Kubernetes and above. And then we have another team consists of 8 people who are infrastructure and network level. So we are currently on an Azure platform, and this is just a screenshot from the Grafana dashboard we have. We currently have 18 clusters. This is just the production, and we have a bit more on the tests. Our goal is to have 90% of all the workload we have at Telenor Norway to run in Azure. And today we have around 400 developers who are using the platform. So as you can see, we have a bunch of clusters, which means we really feel the pain when you're not having a good multi-cluster setup. But before I jump into that, I just want to discuss a bit why we actually need multi-cluster in the first place, because it's far from a silver bullet. There's a lot of cons, but first the pros. We have a hard requirement on the isolation problem. There we need to have different security zones. So we have, for example, an exposed zone and a non-exposed zone, and then they need to be really hard separated. They can't be separated just by namespace and network policies and so on. And then another benefit is that we have specialized clusters. So, for example, we have a cluster which only runs stateful workload. That means we can be a bit more rough with the other clusters because they don't have any state. Another one is that we have a concept called cluster as a cattle, which we're not all the way there, but it means that we can also treat the clusters more like cattle, and similar to how we treat our containers, we can just throw them if they're not working and then start up a new one if we need it. That makes it much easier if you want to do upgrades which require more hands-on. There we can just throw it away, move all the workload, and we have a new cluster. It's still a work in progress, but we're getting there. So over to the pros. Running multiple clusters, it's hard. There's a lot of complexity, and there's operation overhead. In the beginning, we had multiple repositories where one repository controlled one cluster. So when we needed to do a change, we needed to update in all the repositories to actually roll out, which was really painful, and it didn't work out. So 2 of the technologies we use today to handle our multi-cluster, it's probably on the right, it's the more familiar one. It's called Argo. It's basically a GitOps implementation. It has a great UI, and also it's very nice for multi-cluster setup with their application set CRD. In Argo, you basically have an application which says how to deploy your app, and then you can also have an application set CRD, which basically generates the application. So in our case, Argo knows about all the clusters we have and then just deploys it when we say when it needs to. The second one, it's called CUE. It's a data validation language. It's a fairly new language. It's very great for validation, templating, and also basically keeping your configuration dry, so you don't need to repeat yourself. It's from the creators and maintainers are from the Go community, so it's fairly similar in syntax from Go, and also one of the main creator, he is from the initial Borg team. So for Borg, it's basically the father of Kubernetes, and he's also the creator of GCL, which was the language used for configuring Borg. So these are seasoned players, and it's not a weekend project. So the demo I'll focus on today, it's very high level. We have a management cluster and we have a worker cluster. The management cluster deploys everything into the worker cluster where Argo is running. And if you have any questions while I go through the demo, so please just raise your hand or just ask the question so I don't lose you. So, yeah. Correct. So the question was if we have a single Argo instance in the management cluster and not anywhere else, and we only have it in the management cluster. Or this is a simplified version. We have the hard security zone where we don't want to. We say we have different security zones for we're running multiple instances of Argo per security zone, but I don't have it in the demo here. So I have two demos. The first demo is just a short introduction to CUE and Argo, and then I'll move into like a full-fledged version of how we do it internally. The repository is called cluster add-ons. So we give add-ons to your cluster, and then you deploy it. It's a simplified version, so it doesn't include all the features we have, but I think it's nice to start simple so we don't confuse ourselves too much. So here I have an application set, as mentioned. It basically generates an application based on the template we give it. So here's the template for the application. And it contains a generator, which is can you see it on the zoom level, or should I zoom in? And it contains a generator called a cluster generator. So this one, it knows, Argo now knows about all our clusters. And then we do a selector on the label. So if any other cluster is labeled with type production, then it automatically generates the application set. And we do some templating here. And not get confused now. This is similar to Go templating. This is fast template if you want to be technically correct, but this is nothing to do with CUE. This is purely Argo. So, and here also in the application we generate, we also have a Helm and passes some hard-coded values in a string. So this is YAML again, but it's a raw string. But even to complex it a bit more, then we also have a config, which is a JSON. So in CUE, you can do imports of YAML and JSON and OpenAPI and other specs too. So if I go ahead and do that, I am just let's move to the correct. If I do this, now you can see the app set here, it's generated. So here we have CUE on the left and the YAML on the right. So it looks fairly similar. The only difference is that we have a package called example, and then we have the CUE here, where if a struct, it's a basically object. If it's contain only one attribute, then it collapses the whole thing. So it gets this horizontal, which increases readability, and also you get rid of this annoying YAML bugs where you forget to indent. However, we still have the hard or the raw string, which is a bit annoying. So we can improve this with the import command. Here I'm using almost the same command, only I add recursive flag. So what happens then is that you can see suddenly it got some imports. So this is very similar to how Go does it. Here we have encoding YAML and encoding JSON. And you can see here, suddenly it did convert this from the raw string to YAML, or to CUE, which is then marshaled here. So it adds also this strange alias. So it doesn't need to be this alias on the top. So we can also simplify it by just renaming it. I just want to show you that you don't need a strangeness. And also here it gives also an alias, which we can remove. And the same thing, we can also remove it here. So this is fairly nice because now we have CUE all the way. We don't need some strange raw string, and we can use all the CUE feature. We can, yeah. So this is imported from YAML to CUE. And you can also export the CUE, or you can import YAML and export JSON. It's very flexible. It just unifies everything. And here we can still have the benefits of CUE. We can do for loops or whatever. Continuing on, we have a next command. But before that, I want to just show you here, it's in the same folder. I have a file called schema.CUE. And now we're getting into more cool stuff for CUE. So in CUE, we can import Go definitions. And that's really nice when you're working with Kubernetes, because most of Kubernetes is written in Go. So we can basically take any API or CRD and then convert it to CUE definitions. And how that works is that first I need to create two modules. I need to do a Go mod init and CUE mod init. They can figure out where they got the inspiration from. And then you can do just normal Go get to get the packages for API machinery and also the Argo package. And then finally, I can just use the CUE get Go on the path I want to import. And what happens then, if you go to the CUE.mod file, which is created when you create the module under gen, there you can see the actual CUE definitions, which is generated from the Go files. So for example, here's the application set definition. So this is a super powerful concept where you can import, especially in the Kubernetes world. So as I showed you in the schema.q, here I'm saying that a struct called application set, and it's a map. So if you're used to Go, this is a map, but you don't write it like that. It's just the key is a string and the value is an application set definition. So I'm saying that if anything application set, it must be a string on the key, and the value must match the application set definition, which I just imported. However, when we have imported now, it doesn't match this structure. So we can fix the import by using this command. Here, this is the same command as above. However, the difference is that when I do the import, I add the -l flag and get the kind value, and I call a function calls from the strings library to camel, and then also takes the metadata.name and add it. And now we can see that it matches the schema. So it contains the application set, guestbook. So if I want to then check if my schema actually works, then I can do a CUE.eval. And here we can say what's happening, because now we have said that the body inside of the struct, it needs to match the CRD. So here you can see on the path, it says application set.guestbook.spec.template.metdata, field not allowed. Metdata makes sense, it probably some typo. And here you can see I have a typo. So that's a very classical example when you do and work with YAML. I got the fat thumbs, so I make always mistakes. So it's really nice for help me to get some validation early on. So now I don't need to deploy everything, go maybe through some pipeline, which take 5 minutes, which is enough to me to start wondering about life, and suddenly I lose track of where I am. Now I can actually get the feedback instantly. So now I can just import the YAML again, and then do the CUE eval, and I can see the output again. So this is just a quick introduction to CUE. Any questions before I move on to the next demo? Okay, so this is just a diagram I have to make it a bit more clear about the next thing we'll showcase. So on the bottom here, we have the cluster add-ons, which is the repository, and it's basically, I try to mimic how the directory works. We have 3 important directories inside the repository. It's called deployments, clusters, and charts. Then we have Argo running in a management cluster. And to bootstrap, I first need to do Helm install on Argo in the management cluster, and then I apply this first application from Argo, which is called cluster add-ons. That application, it says that Argo, you need to look at this deployments directory. And in that deployments directory, there's a bunch of application set, which we have generated from CUE to YAML, which it picks up. And those application sets says that you need to apply or generate this application if this cluster contains this label. And then when that application is generated, it tells it to look at the charts at the correct path, and then it finds a Helm value, just a normal Helm value in YAML. And then Argo knows how, okay, this should deploy to this cluster. That's like the high level overview of what I'm going to show. So as mentioned, here's the deployments directory. And here we have the generated YAMLs from CUE. So we have our definitions in CUE, but we generate a YAML, which is what Argo picks up. So Argo doesn't know anything about CUE. So for example, here I have very similar to how we looked at. It's just it prints out the application set on the bottom because it's generated. But here's what I've just told. It's the generator cluster, and it's also a match label selector on the cluster.example.com/ArgoCD enabled. So if I have a cluster definition which has that enabled, then it generates this application which tells it to look at my repository under cluster add-ons charge ArgoCD. And then it looks at this is the fast template, not CUE, the YAML value file. And the destination server is here, which is picked up from the cluster definition. So if we change our directory to the cluster add-ons and deployments, and we type in the same CUE import thing, only import, for example, the ArgoCD YAML, which was this we just looked at. Now we imported this, and I can move it to deployments. And I can just rename the package because all the files in the same package needs to have the same package or the same directory. And then I've now extended my schema.CUE a bit. So initially we only have the application set, which says that the value must match this application set definition. And that I also mentioned in the beginning that we can do templating. So this is how you do templating in CUE, or at least one example of it. Here I'm using some hidden fields, which means that it shouldn't be printed out when I generate it, but then it helps me to create some more logic. And also what I do here is I take the name of the application set and do an alias for it and call it ID, which means I can put that variable into other strings. So here I've created a pretty nice template, but I also add this star thing, which says that the default value is this, or it can be a string. So it allows you to overwrite stuff if you need to. And the same thing here, we just say that the namespace should be ID, which is the name of the application set, or you can overwrite it. And I can do also some other manipulation. If you're familiar with Go, a lot of the Go packages, they are available in CUE because CUE is written in Go, so they have just created a small wrapper around the Go function. So it's fairly similar if you're familiar with it. So as I mentioned, we have created this template, and I've just imported the whole YAML. Another really cool thing about CUE is that we can do CUE trim-s to simplify it. So here I'm just saying trim whatever stuff that's not necessary. So if we have our template, that means that everything should be basically removed. So magically it understood that, okay, we have this template and this stuff matches this structure, the application set. Okay, let's just remove everything that's not needed. And this is really, really helpful when you do refactoring, or you need to do refactoring across the whole thing, or you have just some old stuff laying around and you want to trim it on some template. Then you can write the template, do CUE trim, and see that you're constantly just removing a number of lines. So I've gone ahead and already created this application set ArgoCD, and everything is templated out. And then I'm also defining two other application set here. One called Grafana Agent Events, and then I'm saying that the chart name, it should be Grafana Agent, because what I call an add-on is like an instantiation of a chart. So normally there's a one-to-one mapping between charts and add-ons. And then I need to create always an application set per add-on. However, here I've reused a chart and just rename it to Grafana agent events, but I'm telling it to use the Grafana agent chart. Here I'm also changing the namespace where it should be deployed. I deploy to observability, but I can also add like skip CRDs that it shouldn't apply those from the chart. And then we take these and we generate it to YAML. So how that looks like, it's in the gen_tool.CUE. And CUE has a small scripting side of it. Be careful, scripting in CUE doesn't work for everything. It's a bit difficult to debug sometimes. So don't write everything in CUE. Maybe sometimes a nice bash script can help. But it just shows the case that here we have more tools, basically IO related packages, where I can create some files, I can print stuff to the standard out and so on. So what I'm doing here, I'm just removing the generated folder, which is this folder. And then I'm just creating the directory again. And then I'm looping over all the applications that I have. I take the key, which is the app set name, and the configuration. And then I do some funky stuff here, which is CUE syntax. I shouldn't go into detail about that. But then I'm also saying that the file name, it's from the app set name. And then I'm doing YAML.marshal, which creates the file. Then I'm just printing out that I've created the app set name. So then I can type Q command gen, and we can see the files in YAML. They are now generated. So that's the deployments side of it. And then I can move over to the chart. So the charts are Helm charts. And the only thing we do there is that we create an abstraction above the values files, because the value files, they're fairly similar for every cluster. So I'm only creating like an API. If you want to use this chart, then you need to define this. And then it's generated to YAML. So here I have instead of a values.yaml, I have a values.CUE file, which has the package ArgoCD and also a definition. So a definition in the CUE, it's just a hashtag. And then I'm saying these values are available here, and you need to set this. So here I'm saying client ID must be a string, and the cluster, that's a list, which contain this struct. So we need to fill out these values in order to actually use this chart. And here I have also a bunch of other values that needs to be configured when you need to use the ArgoCD. But I can also then reference the client ID, which is specified up here. Then I can reference it later on. So I don't need to duplicate. So when I do a change, then I can know it's propagated properly. So now we have defined the ArgoCD chart, and then the YAML file. It's finally then generated to this, or the CUE values.CUE is generated to this. So here you can see the cluster. It's generated. And you can also see, for example, that which type of add-ons which should be enabled. So here we have ArgoCD enabled, which matches our application generator, application set generator. And then here we only have Grafana agent events and logs, not the ArgoCD, because we don't need ArgoCD other than the management cluster, because this is the management and this is the worker cluster. Then the next question is, how do we define a cluster? So here I have a definition of the P management. Here I am defining a cluster called P management in the clusters package. And there I'm only defining one add-on here. So this add-on is the ArgoCD add-on. And then I'm importing it from the charts. And then I'm using the chart definition. And then I do a unification, basically just opening up the struct. And then I define my other values that needs to be defined. So here's the client ID. And then I do a for loop for generating the clusters, which loops up over this cluster definition. Then I do for cluster name and cluster config. Then I take this other import I have here, cluster metadata dot cluster, and I do a lookup on that, and I can fetch some other cluster metadata stuff. So here I'm getting the CA data server, which are imported from this definition. So what I've already done is created 2 clusters, and then I'm automatically generated this file, which is some more additional information we always need for some add-ons. So I have one place to update this stuff, which is then imported to Mother, and we don't need to change and hope for our change doesn't break anything. And then we have the P services cluster, which is the worker cluster. And here I'm saying it should be in the prod environment, and it doesn't have any other add-ons, or not specifically. But sometimes we need to deploy some add-ons across a bunch of clusters. For example, in this case, I'm using Grafana Agent, which provides us with log collection and events collection. And that needs to be installed on everything, but I don't want to copy paste that my definition should be installed. So what I do, I have a schema.CUE, which has a cluster definition here. And I take for example, in this case, I give it a set of default add-ons. So these add-ons must be deployed for every cluster. So here I take the Grafana Agent chart and rename it to the add-on called Grafana Agent Events. And I say that the agent type should be events. But here I'm also saying that if the environment is prod, and that I can know that that's the only opportunities to have. It's either prod or test, because that's defined here. Then you can set target host to the Loki instance in test, or in prod in this case, or test in this case. And the same goes for the Grafana agent. And here I'm also doing a validation of the cluster name, so we can add some more validation. Here I'm just taking the environment and taking the first character from it, and then saying this must match the regex. So how that will look like is that if I just, for example, just call it services, that I can get some feedback when I call make gen. Here I can say that the cluster services name invalid value services auto banned. Here you can see the regex in much the p dash whatever. And here also define the Grafana agent events from the chart, so you can go take a look how that looked like. Because you can see it's a bit more complex. So here I'm saying, again, this agent type must be logs or events, and it must have a cluster name and target host that must be filled. Then I give it like a baseline definition. This should be true for whatever agent type you use, and then CUE just merges the structures together, or they unify it. And then I'm saying giving it some special definition or some config if it's logs, then I set these, or if it's events, then I set these. And that's just merged together. And then, of course, we also generate this, which is not here, of course, because I need to do this make gen again. And then you generate to do this YAML. This is just a YAML for the Grafana agent, and this is for the events one. So now we've gone through the repository, and I can actually see it in action, how that looks like. So this repository will be available afterwards, and I've linked it in the end. So you can take a look and take your time to actually go through what I'm doing here. So I've already set it up. So first, this cluster is now empty. So it's just the basic pods that's installed when you create an AKS cluster. Then I'm doing just Helm install for ArgoCD, where I just take the values we generated for ArgoCD. So here you can see that the Argo, it's basically been bootstrapped into the management cluster. I'm just getting the password for the ArgoCD instance here. Then I can just do port forward. And here's an empty Argo. So as mentioned, then we need to do the application, the first application for Argo, which is what we call the cluster add-on application. What this does is that it looks at the repository we're currently in, and then go to the cluster add-ons path, as you can see here, and the deployments, and generated where are the application set definitions we have there. So we can go ahead and apply those, and then we can quickly jump back. And here we can see the cluster add-ons application. It's picked up the 3 application sets which we have. And then it understands also that it needs to install the events for both P management and PF services. So here we can also take a look at the application itself, and you can see it's up and running. And if we want, you can see there it's installed. This is the P management. But if I switch context to the P services, here I can, and then here's the Grafana agent events and logs just created from P management to services, which Argo is not running here, as you can see. So any questions? Because I have another demo. This is sort of the end of the cluster add-ons, but I also want to, if I have the time, go through how we do the authentication from P management. I think it's a bit interesting. Yeah. Yeah. So it has 2 modes. Either it syncs periodically, or you can also do install hooks. So if you have a change in the repository, you can send off a hook to ArgoCD, so you get like instant response instead of waiting, or what I do, just clicking the button for a sync. Yeah, so then you can install it with the normal Kubernetes secrets, and that's for accessing the repositories or Helm charts, OCI charts. It's a very good support there. So on the Bootstrap, we need to apply it manually. Any more questions? And sorry for those on the recording didn't hear the question. I forgot to repeat it. No, just feel free to interrupt me if you have any questions. So this is not the best to read, but we can try. So this is just from the README. As mentioned, we have the management cluster, talks to the worker cluster. And I've already gone ahead and installed the 2 Kubernetes clusters. I've added some additional flags for this command, enabling OIDC issuer. And the OIDC issuer is basically in Kubernetes, you have these service account tokens, which is signed. And normally it's just a public private key, which is not exposed. So what the OIDC issuer is, it exposes it to a storage account, which follows the OpenID Connect specification for discovery of the documents. So it's issuing a service account token, which says it's issued by this cluster. And then we can figure out, okay, let this OIDC issuer URL, you can go to that and figure out which key which signed it. And then you can find the public key, and then we can verify that it's actually signed by the appropriate cluster. And then we also enable workload identity, which is a hook in Azure, which just adds some additional environment variables, makes it a bit easier. And we also finally enable Azure Active Directory integration, which I'll come back to understanding what that actually is. Then I also create an identity for ArgoCD, which is in Azure Active Directory. And then I create a federated identity. So I'm saying that I create a federated identity, basically a trust between two clusters. I'm saying that if an token from this OIDC issuer from this subject, and this subject, it's from the system service account from this namespace, which is the ArgoCD namespace, and from this service account name. So if any token sent from this namespace in ArgoCD or from the ArgoCD service account from this cluster, then you can trust it. And then I'm creating a cluster role binding. For cluster admin, you can do some other less privileged, but this is a demo. And then I'm saying that you can trust the user with this principal ID. So and this is installed both in the management and the worker cluster. So when a token comes in from management to our cluster and wants to talk to the Cube API, then it's trusting it because it's enabled with the enable AID flag. Then here I'm generating the cluster metadata information. Yeah, and that's like the magic. And it's very important that you have this rotating secrets, because long-lived secrets with cluster admin privileges, it's something you don't want to have a non-expiry date for, which I guess most people do. And you can also follow this same concept with the OpenID Connect, also with GitHub, which I just did today, for example. There you can apply a trust between GitHub to Azure. I think it's a pretty nice and elegant way of handling secrets. And the last thing I want to show you, it's the last magic. This is normally a normal Helm templating where I'm just creating the configuration of this clusters I have. So it's looping through all the clusters, and then I'm configuring it with the exec provider config, which is from the REST config in Go. It's just calling Cube login, which is another Azure CLI, and it gets its token. So it basically does a trade between Azure Active Directory, trading its service account token to Azure Active Directory and getting it a fresh token back again, which is used then to authenticate with the Cube API. Any last questions? Yeah, so the question was, how do I apply, or how do I make trust between the worker cluster when it's initialized? Yeah. Yeah. How we connect the worker cluster to ArgoCD or to the management? That's not automated. Or we have automated because we use Terraform when we set up the cluster. Then we automatically apply this configuration. So what we do is basically you have this ID or client ID for ArgoCD, and you just apply this cluster role binding, which says trust ArgoCD. Yeah. No, so in ArgoCD, when you say what type of cluster you need to deploy it to, then in the application set, then you need to apply the server. Yeah, and that's in the cluster metadata information. That's this URL. And you can also see, oh, now we closed it, I guess. It's come. Yeah, yeah, then you can see the connection to the cluster is healthy. last questions before I'm finished? Thank you very much for me.